Welcome back, Chemistry 30. So we did this example. We figured out what the two reactions are. So now we just need to make a little sketch to illustrate what's happening here. So I'm going to draw two beakers. Maybe drew those a little bit too big. And in between here, we're going to have a salt bridge, right? Because we need to have something that's going to make up for all the ions that are being transferred. Okay, we'll fill this up with liquid. And we're gonna have what we do. We'll keep the same schematic as before. We'll put the anode over here, so that's where what's considered to be negative, right? So electrons going through here, going through a voltmeter, then going over here to become attached over here to the cathode, which is considered to be a positive. So of course over here at the anode we have LEO, Leo anode, and then we have GR at the cathode. Okay, so losing electrons. What is losing electrons? Right here. We have this losing electrons. So this reaction is happening over here. We have 6I negative breaking down to 3I2 plus 6 electrons. So electrons are being released. So which of these solutions was in there? Let's see here. Originally we have one side containing this and another side containing this. So the iodine is coming from the Ki, so that what must be over here in this side. Okay, so what's happening here is that the Ki in solution here, the iodine part is losing electrons. Those electrons are being deposited onto here and then leaving externally. And then of course we have iodide, so we're going to have to, and as you recall, it was stated that anions are going to be flowing through here. So anions of course are negative, so Cl negative, and cations go to the cathode. Cation, so those are the positive charges. So how do we explain what's happening there? So if we take a look here, it's a little bit different. Before we had zinc, an increase of positive ions, so that has to be, they have to be neutralized by combining with the negatives. This is a little bit different. Here we have the loss of negatives. So all these negative ions are losing their electrons to become neutral. So we need to replace the negative ions. So that explains why we need to increase the Cl negatives in here. So it's not that we're gaining positive ions, it's that we're losing negative ions. Okay, so it's a little bit different there. And then of course, my other solution here, K2, Cr2O7, and H2SO4 must be what's in over here. And the reduction that's happening is over here. So the picking up of electrons. So the 14H plus Cr2O7 plus 6 electrons yields 2Cr3 plus 7H2O. I'm just barely fit that into the screen there. So we have reduction happening here. So here on the reduction side, remember we originally had 12 positives here becoming 6 positives. So we need to replace the lost positives. So of course the cation comes in here and does that. So this is a little different setup than one electrode breaking down and one being added. We could use other items that don't get consumed, and yet we can still have the transfer of electrons by what's happening in the solutions themselves. So one thing is losing electrons. The electrons get deposited onto here. And over here, the electrons are getting pulled by something in the solution. So they're getting used up. And then, of course, to keep these solutions electrically neutral, we have the salt bridge. And remember, the anions need to go to the anode area where the solution is. Because what's happening there, I'm either going to be increasing positive ions or using up negative ions. So the addition of negative ions will help neutralize that, and then the opposite is true on the other side. So if we look at another example here, sorry for the pause there. We'll look at another example here. We'll look at this one. Now this one is very similar to the other ones that we talked about, in which we have electrodes getting consumed. So given the following oxidation reduction, we have that. Determine the two half reactions. Indicate what's happening at each, which electrode is consumed, which electron is positive, and label it. So if we take a look here, zinc is going from 0 to +2. Look at that. And we have 3 of them there, but don't worry about that. Just let's figure out what's being reduced, what's being oxidized. So here we know that's being oxidized right there. And what else has happening? Let's look at this. Oxygen is -2. -2 times 3 is -6. We need to have a charge of -1. So that means this chlorine must be +5. And over here it's -1. So yes, that is being reduced. All right, so we'll work out those two reactions. We'll put the reduction part over here. So ClO3 negative going to Cl minus, and over here is zinc going to, whoops, Zn2 plus. All right, so I have that. So let's balance each of these, and then we can kind of get hints of what we're doing here. We know it's in an acidic solution, and we know we're going to be adding some water, etc. So first of all, these two are balanced, and there's no oxygens, there's no H's, so all I have to do now is balance charges. So of course here I know that my more positive area is over here. So if I add 2 electrons, then it becomes neutralized. So of course I know that zinc is becoming oxidized. Over here I have 1 chlorine and 1 chlorine, so we're good. Oxygens though, I am deficient on the right hand side, so I need 3 oxygens. So I get that by adding 3 H2O. In that process I'm going to be adding 6 H's, so I need to add 6 H's. And looking at charges here, I have 1 positive here, but I have 6 of them. Over here I have 1 negative, and I only have 1 of these. So that's going to be a total of 6 positives, 1 negative, so that's 5 positives. Over here I have 1 negative. Over here I have 3 neutrals. So over here that's a total of 1 negative. So of course the more positive side is over here. So I add electrons, and if I add 4 electrons, or sorry, if I add 6 electrons, that'll make this side -1, which will balance this. So 6H plus ClO3 negative plus my 6 electrons yields that. So if I compare what I have at each side here, taking in 6 electrons, giving up 2 electrons. So yes, to make this perfect, I'm going to have to multiply everything here by 3. 3Zn, 3Zn2 plus 6 electrons. And if I was to, of course, add these two equations on the left-hand side, I'd have 3 zinc, 6H pluses, 6H pluses, ClO3 negative, ClO3 negative. And then the electrons would cancel. On the right-hand side, I'd have Cl negative, 3Zn2 plus, and 3H2O. Look at that, it all works out. So the only thing here that's left is the sketch. So I'll draw the 2 beakers, the salt bridge. Over here I'm going to have the anode where oxidation occurs. It'll go through a voltmeter and register a voltage. Then over here I have the cathode, which is where electrons are going to be gained. And over here I have a salt bridge, right? And I know that anions need to flow this way. So if I use the sodium chloride here, I'm going to have that. And over here I'm going to have the cation going that way. So to figure out what's happening here, what's being oxidized, what's losing electrons, right here. So guess what? It's the zinc this cathode is made of zinc. So I have Zn, my 3 Zn's, making zinc ions in solution and releasing electrons. And then over here on this side, I have this reaction happening. 6H pluses, oops, guess we need to see what's going on here, plus ClO3 negative, taking in 6 electrons to make Cl negative plus 3H2O. Okay, so it doesn't say what the cathode here is made of, but I do have this happening here. Okay, so I have positives turning into negatives, so I need to replace the positives that are being lost, so that's why I need to take in the sodium. So over here, let's see if I answered the question. So determine the 2-half reactions. There they are right there. Indicate which reaction occurs at the anode and which at the cathode. So we could say this is B. At the anode we have this happening, and at the cathode we have that. Which electrode, which electrode is being consumed? So I could say zinc, which is called the anode, is being consumed. And then D, which electrode is positive? So over here, cathode is positive. And E, sketch a labeled diagram. Well, there it is right there. All right, so that's how you do it. So it's kind of a tricky process, but really you're doing what we did in the previous section here, and then just simply labeling it. And there's a certain method that you could use. I like to put the anode on the left, the cathode on the right, because it's easier to memorize that. And of course, in the salt bridge, anions, which are negative ions, flow to the anode. Cations, which are positive ions, flow to the cathode. Okay, and then you can't go wrong that way. All right, so the assignment, you have, I think, 2 diagrams like this, plus a few other qualitative questions. You should be able to do that no problem. All right, we'll see you again.